c'est bon. Bonjour, bonjour. Ah, ça va être nickel. Hello. How are you doing? Going good? You can hear me? Yes, it's okay? Okay, perfect. So I'm, maybe my presentation will appear. Okay, so we'll talk about how to build interactive worlds with Unity. So I will go over, I think, everything, almost everything in Unity, a bit flying over it. I will try to do a live demo on the back there, if you want. And yeah, that's it. Have you played this game? Do you know this game? No, Harold Lalibut. It's a fantastic game which was just released, I think, a month ago. And these are the images in-game. It's pretty incredible, the visual style. And it was made by a very small team, and they took 10 years to do it. It's pretty crazy. They did the characters in real. They scanned the sets. They did everything in reality. Then they modeled everything in 3D. And then put it into a game which is 6 hours long with a crazy story. Yeah, it's one of my favorite games of the year. So I'm Mathieu Muller. I'm product manager for graphics at Unity. I've been working for 22. This year is going to be 23 years in real-time graphics and 3D programming. And I've been at Unity for 10 years this summer. And yeah, that's it. So who is using Unity here, by the way? I just wanted to know. Like, was a few people? Are you using it like every week or every week? Yes, a few people. Who has never used Unity in his life? Okay, no, it's good. No worry. So it's just to know how deep I go and so on. So just for the people who don't know, so the Unity Unity is used by about 1.3 million creators every month, so which are active users. And what is crazy is really what we did since almost the beginning, which is supporting it in multiple platforms. And so this number is pretty crazy, right? The number of gameplay per month of hours which are running in the engine is 5 billion hours every month. Like our engine is running during 5 billion hours, running on multiple devices, on multiple games, and so on. And there are 4 billion downloads every month of games made with Unity, which is also pretty crazy. So I'll show you a few examples of games which were released in the past 1-2 years, just so that you can see the kind of games you can do. The versatility usually with Unity is the fact that you can do almost any style, like VR games, 2D games, 3D games, stylized, realistic. Here it's a lot of indie games in this reel. So what is very impressive here is like most of the games that you've seen are made by a very small team, like sometimes one person, sometimes 5 or 10, very rarely above 20 people in this reel in particular. Also, if you look at this, maybe you think about what kind of games you would like to make. That would be interesting, like when you look at them, what kind of style. That's very important. I show you another reel, which is about games which are made by bigger teams somehow, so that you can see. So yeah, it's very important when if you decide to make a game in your life, you download software to do it, that you know what kind of game you want to do and what kind of game you can do also, which is very important. Because if you have something in your mind which requires 50 people and tons of artists, then it will never happen, and then you're disappointed. But it's very possible just one person actually doing a game which becomes very successful. I skip a bit the videos for now. Let's play a game maybe, very quickly. These are some of my favorite ones since I'm at Unity. So maybe let's do a game, right? You raise one hand if you know it, and you raise two hands if you played it, right? One hand if you, okay? Une main si vous avez joué, et une main, okay? I tell some names. Okay, my preferred one all time is Inside. Okay. Oh, so all the people who are not raising one hand. Yeah, like you should really, like, I think everybody should play that. I think one of my second favorite one is Firewatch. You know Firewatch? Ah, very good. It's great. Oh wow. The one I play in the plane, Mini Metro. Have you played that on the telephone? Oh, it's very good. Oh, you played everything. What else? Alto's Adventure, have you played that? It's a surf game, which is in the desert. It's really cool. Yeah. If you have kids also, it's a really good game for the kids. It's really nice, very calm, beautiful graphics. Also if you have kids, Pikuniku, have you played Pikuniku? No? Yeah? It's such an awesome game. Like if you... Yes, kind of the same, yeah. But Pikuniku is a fantastic adventure, and you're doing battle dance with robots, and you're fighting against toasters. It's really, like, it's crazy, and it's really nice. Okay, what else? Oh, 12 minutes. 12 minutes, have you played that? Ah, it's an awesome game also. Like you enter a room, and you get killed after a few minutes, and then you restart from the start, and then you have to find the things to survive during 12 minutes. And during the 12 minutes that you will survive, you will understand a huge backstory of the game. It's really, really nice. Untitled Goose Game. Have you played that? Untitled Goose Game? Okay, wow. So many games you need to know. Okay, let's, and Dordogne, actually, I want to highlight this one because the creator of Dordogne, have you heard about this one? It's like almost an animated film. It was entirely painted with watercolors by hand. A huge work, and the creator is here these days, so if you find him, it's really amazing, like all painted with watercolors. I think there were like hundreds of paintings, originals to make the game. And it's a beautiful game about your family, about understanding your grandparents and so on. So it's a kind of time travel in the mother, like in the house of your grandmother. It's beautiful. Okay, so let's move. Yeah, of course, Unity is not just used for games. It has been used in many industries. So if you learn Unity, you can work in a lot of different things. We were visiting today Sheila, and we were discussing about how maybe you can do visits with virtual reality or events. Like there are many VJs who are using Unity around the world to create like live visuals and concerts. You can work in medical as well. There are some surgeon simulators which are very important. Like today when you get an operation, for example, very often they just put a camera in your body, and so you have simulators which are running inside of Unity and just recreating the entire things, and the surgeon is working exactly like in a real body. It's really impressive. And there are also many trainings also online, and car configurators. Actually, I don't know if you know, but a lot of cars are coming which will be running Unity in the screens now. Like they will be native on Unity. More and more of them. It's also used for animated films. We've used it. For example, back in the time, it was used on Lion King to shoot the entire Lion King movie in virtual reality with Jon Favreau. And it's been used also to make animated TV productions. So some productions are actually on, I don't know if you have Friends TV here, but there are some kids shows which are made with Unity. Sam and Julia and Mo and Lucy. There is even like 2 movies which used it, which were on theaters as well, rendering with Unity. This one, Journey to Your Land, it was all rendered in Unity. And there are also a lot of VR experiences as well. There are also a lot of VTubers in Japan are using also Unity to do live streams, using a virtual avatar. It's very huge in Asia. These are some of the film productions. Okay, so very quickly, if you want to use Unity, so just to explain, we have multiple versions. So we were releasing a version every year that we called LTS, which is a long-term support. So which means it's usually the version that you use to ship your game. So the way we were doing it, we were doing, for example, 22, and then 22.1 was the first features of the version 22, then 22.2 was the second set of features, and then sometime 22.3 or not. And then after this, once we landed the features, we wait for 6 months or 3 months, and then we wait that it stabilizes and it becomes long-term support, which means that, for example, 22 LTS, we already had 21 subversions to fix the issues like every 2 weeks based on the feedback that we receive, because we run on so many platforms. And usually people tend to upgrade to LTSs when they are here. So more than 60%, for example, of the project are on 22 LTS. Mobile games, sometimes, like you have so many players, you don't upgrade so often, so sometimes they're on 21, but that's it. And we've released about 50 plus features, for example, just in 22. And now we are releasing Unity 6. So Unity 6 is kind of like we are wrapping up like these cycles since 29 to 22. We've been releasing lots and lots and lots of features, and with Unity 6 we are trying to wrap up that cycle and having a long-term, like a longer cycle of release so that it's more stable. Like we think we have enough features at the moment, even people don't have time to try them all. And so Unity 6, sorry, is going to be a bit longer. It's not going to be a release every year there. So the version after this will come a bit later. So you install the Unity Hub, you just go from there, and you can create a new project. You have different templates that you can choose from, depending on what you want to do. It's very important to take the right template when you start. If you look at making something on PC and consoles, which look super high fidelity, you can use HDRP, and you have some samples to start with. If you want to do a cross-platform game or stylized, you can use URP. It's very important to choose the right one when you start. Then sometimes, if you're alone, you can start by just having your project locally, but very often, you can be very frustrated if your project shuts down and you lose everything. So it's very important to use source control. So source control is a way that you put your code into the cloud, and you will be able to retrieve it from another machine. You will be able to add somebody else to work with you, and you will be able to collaborate. And you have different systems. So some people use Git, some people use Perforce, and we have also our own system, which is a company which joined us called Plastic SCM. Now it's called Unity Version Control. And this is very easy to use. When you create a new project, you can say, I want to use version control, and you just click a checkbox, and then your project will be automatically synced with the cloud. You can add 3 people for free to work with you, and you can start working like this together. So it's very important to have source control so that you can revert if you do something wrong, and so on. Then, once you are set up, like with the first templates, it's important to choose the right packages, because as you've seen, you can do 2D games, you can do 3D games, you can do VR games. Some might require add-ons, and these add-ons are in something called the package manager. I will show you very quickly after. And here you have tons of packages to help you. So many times you find what you want there. So then you want to start making your game. So you want to build your environment. So you can start. We have something, one of the packages that I was just mentioning is called Pro Builder. And it's a package which allows you to do some kind of some basic modeling directly in the editor. You can create very easily stairs and ramps and blocks. You can cut windows and so on. And it's a way to very quickly start blocking out your world and see how it looks like, trying your gameplay on it. And it's very nice. It's very nice to use. Then, once you get into productions, many people, when you get to an ambitious game like, for example, I was visiting Ubisoft this week for Prince of Persia, and they have 300 levels, and they are generating them procedurally in ODYSSEE, so that it's a bit faster to build, for example. Then we have terrain tools, so you can create a terrain, paint, details on it. Again, there are some packages on the package manager to have more tools, which, for example, are simulating erosions and some additional things. And yeah, if you are designing your game, like for the people who never made a game before here, maybe, so when you build something, don't just build something. You have to think about what you want the player to do. And then when you know what he wants to do, you build so that he knows directly that he is supposed to do this. Like if you start the game, don't make something which you can go in the back of you, because if you want people to go forward. So start with a wall behind you, for example. If you want him to know if he has a choice to go left, straight, or right, then make it appear like 3 choices in the way you design your game. If you just want him to go straight, then kind of make him understand that it's supposed to go straight and he doesn't look around. So yeah, tell him where to go. Then it's also very important to dress for performance very soon. Like if you start your game at the top of the hill and you see the entire game, like you know that you will have problems to run your game with good performance. So sometimes it's good to think about all the things you want to put that will need to run, and then make sure that the way you design it will hide the rest that you cannot afford rendering, for example. And then you have to dress for fun, right? It has to, like, you can put things in your level which are maybe not useful for the story, but just for the person to have fun. You know, like for example, if you want him to go straight, like in this moment, you maybe want him to get used to the character controller. So maybe you make something where it's fun to jump on the side, where it is kind of like, oh, I like playing that game. Like a very good example of this, Gorilla Tag. I don't know if you play that. It's a VR game where you're just supposed to, like there is, you start, it's a multiplayer game, and you're like maybe I think 8 people. You can be 8 people, and one monkey is your monkeys, and one is red, and then the red has to chase the other ones. And then you just have to touch, then the other one becomes red, so it's 2 red, and then they chase people. And this game is funny because like visually it's very simple, but they're really dressed for fun. Like there is a slide, for example, and the direct things that you do, you want to go there waiting for the guys coming and then going down, and there are trees and there are places where you can hide. And just by dressing for fun, it's just becoming a game, you know, like just when you were a kid. Then when you want to go further, you know kind of the game you want to do, you would know how to design it, and you want to model it. So you can use any software, basically, to do modeling, Blender, Maya, Max, ODYSSEE. We also have SpeedTree that we talk about to create vegetation. And also you can find a lot of stores where you can buy already made assets if you want, like the asset store, Quixel mega scans, which are very good for photoreal scans. And there are many free libraries as well, so you can do a lot already with that. We are launching also something, Muse, which is an AI generator directly in Unity, where you can generate like a wooden floor or something like this, and it generates a texture for you. It works also for 2D sprites, so you can say, can you make me a sprite of a cow or whatever, and it generates a sprite for 2D games. SpeedTree has been used for like big AAA games and many movies. Like usually very often when you see a tree in a movie which is a CG tree, it's very often that it's SpeedTree. And if in AAA games, many games are also using it. So it's both a library and it's an editor to create trees yourself. And creating trees is one of the hardest thing to model, because you have like all the branches, all the leaves. You want maybe them in different seasons. Then once you model one, you maybe want a second version of it. So that's why there is one software which exists for 20 years, which is called SpeedTree. And it's part of Unity now. So you can also download the editor for free. And we have some assets on the store where you can also download some trees ready to use as well, and vegetation ready to use. So ProBuilder, that's what I was talking about. You can actually go, like this is blocking out, so just placing blocks. You can actually do textures, you can do some more advanced modeling. Like we have seen some people almost doing like all the game with ProBuilder. It works as well, you know, like it saves you cost somehow. If you're alone and you're making a game, you have to accept that it won't be maybe perfect, but it's good enough, you know, if people have fun, that's great. I can, like, we watched this for a few seconds to see how it looks like. But it's 2 great tutorials that you can watch online. Like this game, for example, was used, I think, Tunic was made with ProBuilder, and it looks super good, right?
To achieve impressive results.
So yeah, we have tons of tutorial online. I will skip this. It's a bit long. Also, sometimes you want to populate things along a line or along some splines. So we have a spline package as well, where you can place splines, you can control how it goes, and then you have an interface so that you can populate things along the way. So you can, like there's a bug with my GIF. But yeah, you can place rows, you can place kind of leaves and, roots, for example. It's very useful. And then once you've done your level design, then you can start already thinking about lighting, because it's going to be important as well. You know, like what is important with modeling is the shape of what you see. But sometimes you want also to highlight something. I don't know if we see it at the top. No, we don't see. On the video there, like I describe you what happens. It's in a kind of horror game, and there is a corridor, and there are lights like every maybe 5 meters, so that you actually don't, you know that something can come here, but you won't see it for long because it will just traverse the lights. And then there is a door opening, so you see the light of the door opening, and there you have somebody coming out, and then when he comes out, he's out of the light again. So it's a way to prepare, like like it really builds like the gameplay. Somehow the lighting can really build the gameplay. The colors as well, you know, like we have simple things like when something is red, it's stressful. When something is green, it's peaceful, and when something is blue, it's really calm. So also use these colors as well, even at the beginning when you do blocking to make your game. It's actually funny to play games and look at the colors and look at what I said, and you see that a lot of people are using this as well. Yes. So, of course, many things to be done. And then after this, like usually the process is once you've done everything, you've done the lighting, then you add some effects on top of this. So for example, for this we have two systems, Shuriken, which is a particle system which runs everywhere, and it's very easy to make particles. And we have VFX Graph, which is a node-based system, which is AAA quality VFX that runs entirely on the GPU, so you can make really complex things with that. Also, sometimes you will think that something is a VFX when sometimes it can be done in a much simpler way, you know, or lighting. For example, if you want to have fog in your game, it's very expensive to have fog, especially on mobile or on PCs, which are even like not very powerful. So you can just place a plane which is transparent. You can put animated textures on top of this plane, and it will fake it as long as it's far away and so on. So think about this. And then you add interactions. So usually in Unity, the first place to go to add interactions is code, right? So you need to learn how to code. But I mean, if you've never coded in your life, don't be scared, because it's actually the best place to code, I think, because you just create a script, then you double-click on it, it opens, and then you have already the functions written, and you just have to write there. And I know some people who made entire games, and they never learned how to code. They kind of copy-pasted code from internet there and modified it a bit, and then they learn, which is pretty amazing. And you have different ways to code. So there is Visual Studio, which is installed automatically when you can install it together with Unity. Visual Studio Code, which is a bit more lightweight, and JetBrains Rider. If you want to, there are some moments where you want to code visually. So we have Unity Visual Scripting, which will allow to do some kind of visual coding, but even more be able to better represent some gaming systems. You know, like sometimes you want state machine. Like if I do this, then if I do this, it must do that, and if after this, it can do this. And it's very good to represent this as a graph. So you can use this. And on the asset store, you have also many different systems that you can buy, which are like either kind of visual coding systems, or sometimes it's already a system designed for something. For example, the first game that I showed you, Harold Lalibut, at the beginning, like the entire mechanic of the game is based on an asset on the store, which is made for adventure game, where you basically place your scenario, dialogues, interactions, and then it will just generate all the code for you to do this. So again, check if you want to do a game which already exists. Maybe there is already something which is doing most of the mechanic, and you can just have fun with the storytelling or the look. And then there is something new, right? Which is, I think, totally revolutionizing the way we code, which is AI. You know, Unity has been here for 20 years now, and when we developed it, there was almost no public game engine available at the time. So when you were doing a game, you were either coding your own game engine, or you were buying one which was expensive, and then you had the documentation and private forums. But with Unity, we wanted to develop an engine which is made for everyone. So from the first days, you have some forum posts about, oh, we released this feature, like the number 2 feature, and so on. And so there is a history of using Unity, with millions of users for years. And now just with ChatGPT, for example, you can ask him, can you write me a code to make a camera which is following a character a bit smooth? And then you just say that. You can say it in French. You can say it in many languages. And it will just generate the code. And you copy-paste it, and it runs. And then you're like, oh, I think the camera is shaking too much. And then it will change his code. You copy-paste it, and it works. And it's pretty crazy, because it's good for people who don't know how to code. It can even explain you can even explain why did you add this line, like, and it can explain, oh, this component is doing this. Yes? Yes, it's totally allowed. No, it's totally allowed, yeah. Because it's just using, it's writing the syntax of the editor. So it basically learned how to write code. So, and it's really mind-blowing. And I know many people who've been working like me, like 20 years in the industry, who are developers, so they know how to develop, and they use ChatGPT or AI systems every day, just because, like, even if you're good, maybe it will take you 1 minute to code it, and here you can start iterating, and then you put your hands on. So it's very, very, very useful. And we are running our own, as I was saying, we have Muse. So it's our own AI system, which is trained on our documentation, which is trained on our forums exclusively, because ChatGPT, you can ask everything. Here it's really made specially for Unity. And it's coming now integrated in the editor, so you will, like, you can directly say, I want to do this in this script, and it's directly there. And it's like the way it will go also beyond is like it will know about your project, so you can even make him like, can you add me a table? Like, is there a table in my asset, and can you put one in the middle of the room, and it will be able to place one game object in the middle of the room, for example. Like this kind of things, or help you doing something repetitive, like, oh, can you select all the mesh renderers and make them and set this option? Sometimes it's hard to just find them and select and so on. So it's pretty cool. The second thing that we are doing with AI, because I was on AI, is, there are things which are very hard to code in a game. Like when you're making an interaction, let's say you're making a game where the player is supposed to draw something on the wall. Like you want, I don't know, a ghost game, and you want to communicate by asking questions, or answering just yes or no by writing on the mist of a mirror, for example, in a room. It's going to be expensive to code something which can recognize handwriting. So you want to embed an AI which will be able to just do it for you, or recognize gestures, or recognize, even for multiple languages when you want to talk with an NPC. And so for this, we have Sentis, which is basically what Unity is doing, which is cross-platform player for large language models. So you put your model into Sentis, and it will use a device to run it so that you don't have to connect to internet. Because many AI systems are required to connect, and in your game, you just want something to run as if it was a code, but it's actually just an AI. If you're interested also by AI, watch Jussi Kempainen from Finland. He's doing a game alone, and he's trying to use AI on everything he can. He knows how to do it other ways, and he just have conclusions if it's faster to do it this way, or if it's slower to do it another way. It's really cool. He's using it for sound, he's using it for generating the images, for the text translations and so on. It's very super interesting, because he's very honest about what works, what doesn't work. Then you can add characters. So if you want to start today or tomorrow doing a game, we have 2 starter assets, a first-person character controller and a third-person one, which are available on the store. And then again, if you want something more complex, then you can go on the asset store, and there are many assets for free or to buy. Usually, because character controller is very specific to games, we don't think sometimes. But if you have an adventure game, you want something that feels nice. If you are into a shooter or something, actually feeling nice is secondary, because you just want something which is super fast. So you don't want to have motion matching or stuff like this. And then you can add physics, of course. So you can add 3D physics, 2D physics. And we have 3 physics systems. 4. The 3D one, the standard one, the 2D one, and then we have 3D dots physics, So when you start creating very ambitious games, like which are very large, which needs to run a lot of entities, so I'm telling bigger studios, where you have a crowd, for example, and when this needs to run very fast, you want to run things super low level on using multiple threads. And for this, we have something called dots, or entities, which allows to be super efficient in terms of memory usage and fragmentation of access. So you need a special physics system for this, basically, so that you can really run something huge, destructible, and so on. So this is 3D dots physics. And then we have also Havoc physics for Unity, which is also based on dots. So if you really want like the AAA quality of physics. And then, lastly, you might want to do a multiplayer game. It's like, I think, more than half of the games played today are multiplayer. And it's very hard to do a multiplayer game in general. And there are actually, it's like 2 multiplayer games are not the same, you know, like depending if it's a shooter, a co-op, a race, a turn-based system. Like you have many systems. So I don't know if it's gonna play. No, it's not gonna play. So on the left, what you would have seen if I could have played, is like we have now oh no, okay. Oh, it's magical. So now we have like a multiplayer center when you can start and say, I want to do this kind of games, and it will recommend you what kind of like systems you should use, because we cannot make one system which runs for everything. So it guides you on like what kind of games you want, like what kind of system you should use, what kind of tooling you need to use, and so on. And now also, like once you're done, you can directly import the samples, which gets you started, and you have already like a kind of games like this that you can start working on. You're sure you're on the right system. Then, if my magic hand is, oh, I love it. So what is very complicated as well is when you do a multiplayer game, you want to test, of course, playing it in multiple players. But you don't want to have multiple editor opens in parallel, and it creates issues and so on. Like people used to actually have one machine, multiple machines, just to be able to test them. Now there is a multiplayer play mode, which is dedicated to multiplayer directly in the editor, which will launch different like game instances and allow you to test things together. It's really nice. We have a lot of investment, like since about 2-3 years in multiplayer. We really hope like we can help like make people be able to make multiplayer games more easily, to maintain them more easily, and so on. So we have netcode for GameObject, which is the simplest multiplayer system. So you just work like you usually do with Unity, and then it's perfect for like small scale games. If you want more advanced, you want to have dots, and so you need to have netcode for entities, which is the system I was talking about before. And then we also have super good third-party services, like Photon, for example, is used in many, many games, so it's an excellent service. And then on top of this, we have Unity gaming services, which is, you know, when you do a multiplayer game, once it launches, and maybe you're super happy, and there are like thousands and thousands of people, then if you don't know what is happening, and it's going to be hard, you know, like which server I want and so on. Like if there is a crash, like analyzing basically all the analytics that you need to have, it's kind of very complicated to get. So we have something called Unity Gaming Services, which are a lot of services on the cloud, where you can just hook them into your game, and then you will receive all the information on the dashboard. You will, for example, let's imagine you do a game alone, which has 10,000 people playing it. Like we have a system which will automatically scale the servers behind for you. I mean, of course, it's something you pay for, but like at least you can scale your game once you started small. So yeah, if you want to get started, I recommend reading this blog. So Multiplayer Resource Roundup. It's one blog post where it sums up all the samples that are available. Some are very simple, so just to learn the basics. Some are more complex to understand how it works in a complex world when you have UI and configurations and all this stuff. Like for example, like this one is a simple one at the top. It's a kind of like asteroid multiplayer asteroid. And the other one there, the multiplayer, my magic hand. it doesn't work. Ah, yeah. Perfect. So this one, for example, Mega City Metro, is one which is using dots entities, and you can have, I think, 120 people playing simultaneously on mobile, and it's a sample you can download, and you see how you can make these kind of games. It's a race game in a big city, like the Fifth Element a bit. Yeah. So you can download the sample, you have all of this, and then you can see, you can modify it and start your game from there if it kind of matches this. Then we also have, if you're doing VR, like it's something which is asked a lot, like when you're doing a VR game, the problem is the fact that you're alone sometimes. So you want maybe to make a co-op experience, even if it's for a museum or for to visit a place. It's nice to be together. There are actually amazing collaborative experiences about the Sagrada Familia in Barcelona, for example, or Cheops to visit the pyramids. So there is a sample coming, which will, again, like a good starting point when you make a VR game in multiplayer. And then finally, probably the last bit, is to add UI. Okay. Okay. No. Maybe can we do next? Hello? Okay. Cool. Perfect. It's really good. Okay, perfect. First thing, so again, we have multiple systems to do the same thing. That's something maybe we won't sort in the future. But we have 2 UI systems or 3 UI systems. One which is very simple for very, very simple UI, like which looks like a bit like a monitor, I would say, like all-style monitor. And then we have UI elements. And UI elements, sorry, not UI elements, EM GUI is a system where you place buttons. If you use Unity, you can see. So you place buttons, you can decide where they are attached and so on. And now you can control them with shader graph, so our visual system to code shaders, which will allow to do a kind of advanced effects. When you do a mobile game, for example, one of the big problems is that it should be less than 150 megs when you publish it. And sometimes just the UI is the textures of the UI are taking too much space. And so using something procedural is nice, and it's possible now. And then we have a new system called UI Toolkit, which is a very powerful solution. You can make more complex UI. It's based on the web concept, so you can do things like you can scroll, you have like complex tree views. It's very nice if you have a game which has a lot of configurations, like management games, advanced simulation games. There is a great talk if you want to watch, for example, Just Dance. Just Dance is a lot of UI because you want to scroll in a catalog, you have to download it and so on. And they use UI elements because they could not have done it, I think, without this system, with our previous system. So it's a good way to learn how to use this. We have also a sample project called UI Toolkit Sample Project, where you can see, again, you can download a game which is using UI to do, it's a full game that you can play. And you have like configurations, you have like all the things that you will find in a typical game, and show you how to use UI Toolkit. Yes. And even like in-game, I think, we will see it after. Like this is the configuration and so on, yeah. In case I'm just sending some tips for the people who are using already Unity. Like if you're doing VR, one big problem, especially if you do for museums, for example, or installations, one big problem is to be able to read text in VR. Because when you render the text directly in the 3D world, it gets very blurry quickly. As you can see on the left, you can have aliasing. So we added a composition layer system, which allows to render the text in a separate layer so that it's really high resolution, and just composite it with your world. So in case you're doing this kind of application, check this. It's coming in Unity 6. Also something that is coming here for the first time, but it's really good. Like I'm super happy with marketing. They worked, like these books. I don't know, maybe I'm old, but like they were like all these books that you could buy at the time, learning, I don't know, 3ds Max and Maya. And now what we've done is like we've done this kind of books, but virtual for now, but they are exactly the same kind of books, you know, like very well made, explaining different concepts. So for example, this one is about, I think, 50 pages, 100 pages, about how to master user interface and design there. So if you want to become like a UI designer in game, you read this book, you master it, and then maybe you find a job, right? So that's it. Oh, I forgot this, and 2D, right? I think a third of the games that were released on Steam were 2D, are made with Unity, and in 23. So just a small trailer so that I can breathe. Is it okay? It's not too long? So many games I want to play. Okay. Up. Okay. So again, the project I was talking about is also like a 2D sample. So you learn how to use animation, how to use. There are specific tooling in Unity to do. Like for example, here the rigging and animation, you can do it all in Unity for 2D. It's very convenient. You can do the level design also. We have tools with tile maps or with splines where it allows to put the sprites along these lines. So it's very easy to build worlds. And we have many samples again. If you want to start, we have Dragon Crusher. We have this one called Happy Harvest. Yeah, you can download it also there. So this one is a kind of like game where you try to collect, you know, to grow crops and you water things and so on, like Alba and so on. And you have like all the game which is playable, and it's using here 2D lighting. So you can do lighting in 2D if you have kind of normal maps or bump maps that will represent the lighting. You can actually have day and night in a 2D game, for example here. You can see the things. So it explains how to use shader graph, how to use like make effects for 2D games as well. Even use VFX graphs that I was talking about to make 2D effects, even if it's like a 3D particle engine at the beginning. Animation. Like all the animations have been done in Engine, for example, here. And you see how you can use the tile maps so that you can directly paint your world directly. And then we have another one which is new, which was released not too long ago. So it's called Gem Hunter Match. Many people want to do Gem Hunters, and they are like hugely successful Gem Hunter games. So it's, again, ready to use system which shows you how to do a mobile game, like a typical mobile game. It's like you can reuse it, customize it. There is an entire set of tutorials to learn how it was built and how maybe you can customize it, how we generated the textures, how we made VFX so that it's cool, and so on. Like how we use again the time map system to do the design of the puzzles. Yeah, okay. So again, there is this great ebook if you're interested into 2D games, and you want to do this as part of your career or your passion. Like just take this ebook, read it on the beach or in the park. Yeah, and then we go to my favorite part, which are graphics. So yeah, is it good? It's okay? We've been 1 hour together. It's a long, long time. Okay, excellent. Do you have questions, just so that we take a small break? Any question? Maybe? Yes? Yes? Okay.
Can you revert back to the last slide? I just want to see the book name. Yeah. Thank you.
Yeah. Okay.
Thank you.
Perfect.
I would like to know if Unity is resources friendly for, I wouldn't say low-end computers, but like,
Yeah.
I would like to know if Unity is resources friendly about the computers. Like, is it easy to use and to render games in 3D, for example, without having a high-end computer?
Yeah, for sure. No, so that's what we I was showing, and I will show actually, that we are doing so many, we're covering so many platforms that, for example, for graphics, which is where it could be expensive, we actually have two graphics engine. One which is more lightweight and done to be optimized on mobile and even on low-end hardware. You can really, as I was mentioning, like it can run with very low battery efficiency on a car, for example. And at the same time, if you want to do something more high-end, we have a dedicated like high-end engine, which will run on less devices, but which will give you like the high-end quality. So you choose. It's very important to choose well at the beginning. Yeah. But yeah, it's our thing. You know, like that's the 4 billion downloads of games made with Unity every month are because it's running like on all these devices. I forgot the number of unique devices we're running on, but it's pretty crazy. I think it's about the population of the world. So yeah, that's really like that's a hard part. You know, like I work on the feature side, but we have like a lot of people working just on making sure that it runs on this on all these devices. Yeah.
I have another question if
Yes.
nobody has.
Yeah.
Okay. I would like to know the percentage that Unity takes after you publish a game, for example. What is the percentage?
Yeah. So I'm not in the business side, but I mean, I cannot really answer. Like, you have to check. Yeah, I mean, if you're making less, I think, than 200K of money, like you're as a company, I think you don't like. Yeah, I'm not sure because I don't want to say something wrong, but yeah. But it's on the website, and it's kind of like complicated, yeah. But the idea is to scale. Like, we don't take if you're making a game which is not usually successful and not usually making money, and down the line we cap it so that it's never like a huge kind of royalty, I would say, or like it's not a huge percentage of your game. Like the goal is to be fair on this. So that's why the model is very complicated. Yeah. Yes. Yeah. Yes.
So I'll take it again. So I'm coming from a bit different world. I'm coming from the embedded world.
Yes.
So, and the majority of the platforms that we're using right now for infotainment and for those kind of
Yes.
things are running other engines, because until now we didn't see that there is any kind of compatibility from Unity with platforms that doesn't have like a dedicated graphic cards.
Yes.
So we are using mainly EMX8, IMX6 processors that are all in one embedded.
Yeah.
So is there any plans to have an engine dedicated for embedded systems instead of having like to have a micro GPU that is integrated like what Mercedes are doing? Because when you are doing those kind of things, there is a lot of cost that will be driven by the engine that you'll be using to run your infotainment.
So, yeah, I'm not expert on this part. I would say like the thing where we open a bit in this direction is through the automotive system. You know, like the fact that we support, like it's really embedded systems. But I don't know exactly the min specs that are there today, so I have to check. But
So I'll just sit.
No, it's good.
Okay,
It's,
so,
it's working.
I know that there is like a compiled version for Linux
Yes.
that we tried to run, but we didn't success in that. So
Okay.
because it's made for Linux that runs a GPU.
Yes.
But right now we don't have a GPU in an embedded system. It's something that is embedded on the microprocessor
Yeah, okay.
itself.
Maybe we can discuss
Yeah.
after, but I think we don't support that actually.
Thank you.
Yeah. And there's no plan, I think. Yeah. Yes.
A question regarding digital twins. So,
Yeah.
so I noticed that you have a lot of templates to use for VR and 2D and 3D games.
Yes.
I was wondering, for example, we want to create something in digital twin, we want to create 3D environments,
Yes.
interactive and so on, and the possibility to retrieve data from a cloud platform or IoT platform. So do you have any kind of templates
Yes.
to build upon?
Yes,
about-
I think we've just released some of them, open source them. I think it's very new. We can check also after, but we've been working again like with digital twin for a long time, and now we build some templates dedicated for this, like a product configurator, for example, and things like this. So I think we released them open source like a few weeks ago, so we can check maybe. I can look on the, yeah. Oh, it's good. Wow. Wow. Questions everywhere. Yeah. And after, yeah, here and there, yeah.
I have a question actually about securing projects of developers, like from reverse engineering especially. I would like to know if there is a tool or something that is coming in new versions of Unity to protect, especially from reverse engineering of getting back the the textures and the objects, especially the the images and so
Yeah,
on.
for
Because
sure.
I know for scripts there is IL2 CPP that protects a little bit the source code,
Exactly.
but for the
I don't
for the
think.
objects and so on.
Yeah, I don't know anything about this part. Yeah, I know that there are tools for multiplayer to guarantee the security there, but I don't like cheat prevention. But I don't think there are things for textures. Yeah, because you end up like, I mean, you can always go into the driver side and download things. So I don't think there is something planned for this specifically. Yeah, yeah. And there is a question there, I think. Yes. There is a mic coming, yeah.
So for example, I have an issue with the coding in Unity, and I don't have any friends that can help me with coding.
Yes.
So
ChatGPT.
what?
ChatGPT, I would say, yeah. Like really try it.
I tried, but it didn't help me right.
Really?
Really.
Okay.
Maybe because I didn't write the right prompt or
Yeah.
something like that, but I didn't fix the problem.
Okay, okay. So yeah, maybe you need to learn a bit, but usually like, if like you can use the visual scripting. Have you tried the visual scripting package as well?
I didn't see it. I didn't see it because I just come last minute.
Ah, okay, okay. So there is a visual scripting package as well, where you
Okay.
can use like boxes basically to create the code.
Okay.
Yeah, the logic.
Thank
yeah.
you.
So yeah, but I really recommend learning how to code. It's always good. Yeah. It's you don't need to learn to be an engine coder. You can just code like the few lines that you need to do to make your game. And with ChatGPT, you should like after very quickly you should be able to learn how to do the basics.
Isn't something there's for example some plugin that help you in coding in Unity?
I mean, the visual scripting that I was saying, for example, or you have also tools on the asset store I was mentioning before, which are giving you already like pre-made, basically games that you want to do. You know, like you start with already, it's called, how is it called? I mean, people are selling some templates sometimes, which is already like a shooter, already like a ready-to-use game, and you can start from there if you don't want to code. Yeah.
Okay, thank you.
Yeah, thank you. Oh, more questions here. Wow, thank you so much.
About the visual scripting thing.
Yes.
Does it affect the engine in some way if I use the visual scripting instead of actual code?
I mean, it generates C# code down the line, so it's kind of the same, right? Like it's just generating code. It's a code generator, basically, right? You create boxes and it turns it into code, which will be compiled like any code that you would be using yourself. Yeah. That you would be doing yourself. Yeah. Oh, there's a question there.
What about WebGPU? Is it better than WebGL?
Yes, yes. So there is WebGL and WebGPU support, which is experimental now, but it's in Unity 6 on the latest version. So you can, if you look WebGPU Unity, you will find a few demos running like the VFX graph, for example, on the web browser. And there is also WebGL support for mobile as well now. So you can run like integrated integrated WebGL games or whatever inside a web page, yes, and see it from your phone. Yeah, it's been a lot of investment there. There is also an integration in instant games for Messenger now as well. So you can create games which will be integrated in the Messenger app that people can share directly. Okay, you don't want to hear about graphics. It's okay.
I just want to ask you a question about like AI because I see a lot of people using AI to either develop their scripts or maybe like create assets or whatever. And I don't know like if it's really okay to develop such a game not using your own touch, but everything that is could be generated, AI generated. So I don't know if that's okay or not.
Yes. So you mean the ethical aspect?
Yeah.
Yeah. Okay. So I'm not responsible for AI. I just know that, like, we really it was the first thing to do when we did AI was to be sure that it's actually ethic first and quality second, because usually in AI today it's actually the balance you have to do. You can do a high quality, but it means usually that you have to go into content which is not yours. So for us, it's really like ethic first, and then we will ramp up with that because it's about that. Like you need to wait that actually people contribute to it so that it becomes like with wanting to contribute to it so that it becomes ethical down the line. And for the code, as I was saying, it's not really like copyrighted because it's really like it's learning how to use the editor. It's learning basically from exactly like anyone from the mistakes that people have done. On the forums they say, oh, I've done like my camera is shaking, and then somebody says, oh, you can add this line, and basically that's what he's doing.
Yeah, because sometimes like they use ChatGPT to generate certain code, and then they copy it to Unity, and they keep like editing everything so it can suit their game. So I guess it's kind of developing the game, not just copying, pasting.
Yeah, exactly. You're developing the game, and the way it's done in Unity, it's not like one code and it's your game. It's like one component. So you cannot really say, copy that game and make it into mine. Yeah. So, yeah.
Thank you.
Yeah. Okay, we continue? Or, more questions? Okay. No, I'm happy to do questions until the end.
Hello.
Hello.
I would like to ask if we can use Unity dots for VR development. Otherwise, if you can share some performance techniques inside Unity for VR development.
Okay. Maybe I will get to that in the end, but yes, you can use dots anywhere. It's really just like a coding, like it's a way to code, basically. So it runs on all the platforms we support. But it's really specifically done to be able to parallelize. So it means like you have a game which is required, which will be more performance. It's highly parallelizable down the line, because that's all about dots. What dots is really to maybe I explain quickly, but like you have game objects right now which have a script, which means like if you have a script for a character to just go straight, for example, and then you want to have 100 characters doing this, what will happen is like you will instantiate 100 game objects, and then you will call for each character go straight. Like the first one goes straight, the second one goes straight, and so on. I'm speaking too much. Oh, no, it's good. But the way to do this efficiently is to say, I have a character entity, and I have 100 instances of them, and in one loop, I make all these entities go straight, you know? And so you need to, the code that you're writing, which is going straight, goes into a process and will be parallelized, and then you can run it this way. So it's really useful for this. It doesn't make your game magically faster. It just makes this kind of use cases a bit faster. There are tons of other usage, but like for performance, that's the main one. Yeah. And for performance, I will quickly touch on it after. Yeah. We continue? You're such a good audience. It's nice. I feel like in my living room. Mm. So graphics. So we have, again, like in Unity 6, we have 3 graphics engines. We have the one that we had before, which is called the built-in render pipeline. And but the problem with that was that it was written in the C++ code of Unity. So you could not really read the code like we were, like the way we were creating it was doing the rendering and then just putting callbacks so that people can put themselves into the code, but they could not really know how it works. You know, if they wanted to remove something, they could not. So what we've done something called scriptable render pipelines, where we took most of the rendering code and put it outside of the editor in C# so that you can look at the code, modify it if you want. And this allows to do custom rendering on top. And we provided, as I was mentioning before, 2 rendering engines. One which is efficient for mobile, which is optimized for mobile, which is not trying to do photoreal rendering. So it's more flexible when you don't want to do this. It's easier because you don't have to unplug everything. However, we have another one, so it's called URP, Universal Render Pipeline, and this is for 2D and 3D. And it works on every platform, so it's really nice when you want to do one thing and then it goes everywhere. Now, if you want to do something which looks real, like I don't know, like a first-person shooter, an adventure game, a sports game, which is kind of like high quality, it's very complicated to do photorealism because you need so many features to do this. And before, in Unity, you needed to buy tons of assets, put them together so that you have nice-looking graphics. And we wanted that people can just open Unity and do something which looks great off the shelf. And this is HDRP, or high-definition render pipeline. So if you want a AAA PC console rendering, and you don't want stylized, super efficient on mobile and so on, like you can go for this. So as I was saying, we have 3 engines. Our goal is to have maximum 2 in the future. So step by step, less and less people are using the old engine. It's just like it's been there and it's very stable, so there are still people using it. But about 90% in 23 of the games shipped on Steam used already either URP or HDRP. So most studios now, when they start a game, they use the new render pipelines. So it's production ready. It's used in tons of games already. It's installed on millions and millions of devices on mobile, so it works really well. And so we spend some time to bring like more features to the new render pipelines, but also like get the same kind of feature than on the previous pipeline. The only thing that you cannot do, we had something called surface shaders, which is a way to write shader by hand and not with a visual code. And it's a kind of framework to do it like in a simple way. And we did not bring it to SRPs. But it doesn't mean that you cannot write shaders by hand. Actually, a lot of people do. It's just like you go from the shader in the pipeline, you duplicate it, like you create your shader, you duplicate it, and then you edit it from there instead of having a framework to do this. But it works very well as well if you want to improve. I won't go to all this list. If you want to get started, again, we have the new URP3 sample scenes. So you just go on the hub, new project, URP3 samples, and it comes with 4 scenes: terminal, garden, oasis, cockpit, which are kind of representing the different things you want to do. And all of them run on mobile, they run on all the platforms, and they show how basically you optimize, you set up your project to make a new game. Before we had this, we released them a few months ago. Like when you open Unity, you create a new project, you know, like how do you know if it's going to be set up the way so that it's performant down the line? Here you can go there, You can deploy it on mobile, it will run with performance, and you can start from there and just like, instead of like trying to find out the information. So ODYSSEE, for example, is the highest end one, so it requires, I think, iPhone 8 something. It's kind of like more towards high-end mobile, we would say. And for example, the cockpit is really representing how you can make something run super fast on VR, where you don't use lead shaders, which are more expensive, how you can resimulate lighting for very cheap. So it's a very, very good way to learn. And the first one is physically based. There is a blog post that we've made, which is super nice, because when you see the stuff, you're like, what do I learn from there? There are in-editor tutorials, so you can learn from there. But we've done at least 3 or 4 talks. If you like, it will take you 2 hours, and you will learn about all the like details about all of this. You know, something. If you use Unity, we learn a lot of things as well. So it's very good to start from there. I show you some videos of it. And you can reuse the assets on your game as well. Like if you want to start, like there are some good stuff really. So this is when you launch it, you have the terminal, and you can go in 3 rooms, and you will have a teleporter in it, which allows you to teleport to the other worlds, which is to showcase a bit like complex features also running into this sample. And then we have the garden, which is showing like lit, so like physically based, but stylized rendering. So iPhone 6s, for example, minimal for this one. And it shows you how to make stylized shaders, how to make VFX. Like it's using a speed tree in the middle. ODYSSEE is using speed tree for the palm trees and vegetation. It's showing how, for example, if you want to have a fog, there is a custom fog in this one as well to show a fog which can work on mobile. There is a custom like water system to have the reflections also, which are running efficiently on mobile. And then there is a cockpit that I was talking about, which is really nice. We bake some light maps so that you have good visual quality, but it's actually very cheap. It's just 1 shader for the entire stuff almost. And it's great for VR. So okay, I show you. So maybe some of the, just a small showcase again, if it works. If not, we can pass. Okay, so it's more some of like to have a reference of more high-end rendering ones that are made with HDRP. Not all of them actually, because it's not, URP is not made to make low-end graphics neither. You know, like you can do high-quality graphics. It's just like different styles. Amplitude Studio, for example, they've done their own scriptable render pipeline. So it's neither URP or HDRP. They made one specially for their game because it's 5x. So it's 4x. Sorry, it's 4x, and they need something custom. We see 12 minutes again. Yeah, I would skip because I think we see a few. It's not all high-end ones neither. Okay, I skip. It's because the time is running out. So I just go very quickly. Who is interesting actually? If you do a game, who will do a 2D game here? Okay. And who will do a stylized 3D game? 2D isometric, yeah. 3D stylized. And who would like to do like a super, like something looking amazing, like a AAA game? Okay, yeah. So I think people doing 3D stylized are winning today. But yeah. So I just show you very quickly if you want or need to make like a high fidelity game, what's inside of HDRP very quickly. So. In the high-end renderer. So HDRP is physical-based units. So it means that when you use URP, when you place a light, the value is 1. You know, and because you want stylized, you want things to be placed relatively. You know, like 1 is 1, and I want one which is a bit less strong, and I put at 0.5 if I want it to be less strong, and so on. So it's very nice to control the light. You can have for example, it's very easy to have the sun, and then still see the lights being turned on, which normally doesn't work in reality. You know, like the sun is 100,000 times much stronger than a light. So normally, if you're outside and you have a bulb, there is no way that you see any light. But if you want to do something realistic, then you have to follow the realism, like the reality of lighting. So you have to follow that the sun has to be 100,000 times more, and the light bulb has to be the right value. So we have physical light units in HDRP. And to help you, because not everybody knows like that the sun is 130,000 lux, so we have small icons to help you, where you can, when you do a directional light, you can say it's sun at midday, it's sun in the evening, it's sun when it's covered, and it will adjust automatically the physical value for you. If you place a light, you can also, again, there is a small icon saying if it's like, is it a street lamp, or is it a lamp in your place, or is it a candle? So that is very easy. Yeah. Sorry? Yeah. Okay. Maybe I'm not sure. Yeah. So, and it's cool. It's in the UX directly. It's pretty convenient. And same for exposure, because if you are physically based lit, I mean, most of us don't recognize every day, you know, because it's auto exposure. Basically, how much light is going in my eyes now is very less than it will be when I go outside. But for me, it feels like it's the same. So you need to have the exposure so that you control how much light is going on depending if you're in or out. So this is again control. You can have fixed exposure. So if you want to, if you control your environment, you can have auto exposure so that you can go inside and outside, still following the rules of lighting. We have advanced light controls as well. So, for example, like if you want to be efficient, you cannot have as many controls on your lights. You know, the inner cone. If you want to have more, like for example, for shadows, you can control the color of the penumbra compared to the rest of the shadow. You can dim the shadow, and all these options cost a lot in the renderer. So, and you cannot remove them usually. So they are all like off the shelf with HDRP. We have light layers. This one is common to everyone now. So that, for example, when you place a light, it can lit only some objects and not others, which is nice if you just want to correct your lighting or if you're doing a cinematic. Advanced shadows, I mentioned it. So we have tons of shadows. Like we have contact shadows to do the small shadows close to the ground because they would be too expensive with the shadow map. We have cascade shadows with a lot of control on the quality. We have ray trace shadows. We have micro shadows, which are creating shadows inside of a texture based on the normal map. And you can turn them on and off depending on your target hardware. And then the big thing of HDRP is the volumetric fog lighting. So you have like all the options for volumetrics. For advanced light controls as well, something interesting is, you know, like a light, for the people who don't know lighting, it's interesting. A light is always control of the diffuse and specular aspect. So when you have a light, it will light, if it's white, it will give a light on this. But if it's a bit shiny, the ground, you will get a specular highlight. You know, it will kind of shine. And these two things, you can separate them. Sometimes you just want light to come, but you don't want to have a highlight on something. And it's very often what you do in a photo studio. You place a filter so that it removes the specular, and you just have the diffuse. And in HDRP, for example, you can control for each light how much you want to, like if you want to affect diffuse, specular, or the two. It's just to give an example of that. Then we have light map, light probes. I will show you this if I have time. Reflections. So all of our systems are thought so that you can pile them up so that you can grow in quality. So you can start with something which is very efficient, but maybe pre-baked, and then you can add some systems on top of this that will fall back on the baked one so that it's more efficient until it's kind of full real time. So for example, for reflections, so in a room where you have a shiny floor, you want to see basically things being reflected, right? So you can place a reflection probe, and you can bake it so that it's not expensive, but it won't be totally accurate. So you can say, I want screen space reflections, so I want to calculate them in what I see. It's efficient. But then, I don't want, the problem is like when I will see outside of the screen, I won't see the information because it's not there. So you say, I can do screen space, and until a moment, I fall back on the reflection probe I've baked so that it's not too expensive. And then if you really want something more accurate, then you can have a ray traced reflections, which will only work on ray traced machines. And then it will allow you to send rays, screen space. When it goes out of screen space, it will go into ray tracing. And after some time, when ray tracing becomes too expensive, you can say, now fall back to reflection probes. And this allows to stack the different systems. It's the same for global illumination. We have the same system. You start by baking probes or light maps. Then you can put screen space global illumination, and then screen space ray trace global illumination. And they stack up, and you choose so that you can pay this even on many hardware. And same for shadows and AO and so on. We have also a path tracer. If you're working on a project where you need to render something very high quality, you can just by basically one button, you can say, I remove HDRP classical rendering, and it's going to be entirely path traced. Like for example, here what you see is path traced rendering of a scene. So it's a bit slower. It takes a few seconds per frame to render each frame. But in the editor, it's progressive, so you can still see it. But it supports the volumetrics, most of our materials, most of our lights, the VFX, and so on. Yeah, so it's in case you're working on a project and need, for example, in a digital twin, the question was there, sometimes you want something, a configurator, but at some point you want to have an image like if it was rendered with a rendering engine. And also, you can export the different layers if you want to do compositing outside as well, that we call AOVs. So we have also something that you had in Unity before was you only had a few shaders available. And if you wanted more, you had to code them or to buy them on the store. With HDRP, but the problem sometimes, again, that they were not working on a system. You have the cloud, which is not compatible, or the transparency of this shader, which doesn't work, or the subsurface scattering. So that's what we wanted with HDRP, having all these shaders off the shelf. So lit with transmission, translucency, stack lit, so that you can simulate the coat on cars, tessellation shaders, and we have advanced transparency management, so that you can have gummy bear or ice things. Then we have advanced VFX, shader graph, VFX graph, I talk about this, screen space lens flares, a physical camera so that you can have physical depth of field. There is an option to make it look like great, but which is expensive, so don't use it in your game. Don't check a physical depth of field. And custom post-process and volumetric materials. Volumetric materials is interesting. You can take shader graph and generate a procedural 3D volume that will be output into the volumetric fog. So you can create a kind of smoke, or if you want to have a mist working around, you can just create a shader graph which will output into the fog. Same for VFX graph. You can output particles of VFX graph so that they generate fog. I think I'm losing you. It's a lot of content right now. No, it's okay. So we have speed tree integration, again, with all the subsurface scattering. We have a decal system. Decals is very important because when you can have very high fidelity textures, but you don't want to have everything being represented. You want to tile things, but you want to break this tiling. So for example, here, it's kind of the same texture, but you have some scratches on the ground. This is where decals are very useful. So you take scratch decals, and you just place them everywhere. They are burstified. What we say, we're using burst. It's a system to parallelize the process of the decals. So you can put a lot of them. As you can see on this place, you have maybe 20, 30 of them, so that it makes the world unique. We have a water system, physical sky. I will maybe do a demo of all this. Volumetric clouds and volumetric fog. And this is a new HDRP water system. Let's see if I have time. Do you want to do a demo of, it's 3:10. Do you want a demo of the water system and clouds? Is it okay? Okay. So I don't have the PC here, so I go on the back. and try to do this from there. Thank you. The mic. So I'm on the hub. I have this demo that I made for GDC. Should have opened this before. Can show you in the meantime. This is the URP samples that I was talking about. Where is it? Oh. Okay. And this is a HDRP sample. You can see it's a small room here where you can walk around. I'm running on a laptop here, so it's still, even if you use HDRP, it's still pretty scalable. I can show you. There is a character controller, as I mentioned before. Okay. So this is where you can start working from. And this sample, for example, showcases a lot of the HDRP features I just talked about, the volumetric fog, the subsurface scattering, the reflection system, the physical lights, adaptive pro volumes. You see the lens flares as well here. So, okay, let me close this. Okay. So here is a little scene. So you can see it's raining. So we will, if it's raining a lot, there will be an ocean at some point. So just creating, for example, a water system is very fast. You know, you just create an ocean. And you can see here that, I will enter play mode maybe. Up. So you can see here that it's raining, but it's missing something, right? It's missing the raindrops on the water. So if you go on the water system, you can see that there is actually a master node for shadow graph, so you can customize your water rendering. And here we made a custom renderer, which allows to render like the raindrops on the ocean. So you just create this shader, which looks like this. So you see it's just a shadow graph shader, which goes into the master node for the ocean, and then you have the raindrops going there. So now let's make it stop to rain here. So the rain is made with VFX graph. Now if the weather is better, so we have a volume system in Unity, which is very convenient. So you place a volume in your scene, and then you can place a second one, and you will be able to override the value of the other volume, for example. And you can blend between them. So for example, here, there is one volume where the sky is, the clouds are like clear sky or little cloudy, and one where it's stormy like this. And for example, this one is a stormy one. And I can just like diminish the weight so that it goes from one to another. And we can see how it goes from cloudy to stormy. And we can see the physical light units working their way, like changing everything because you're based on physical units for the sky and for the clouds. So now if the weather is better, we can diminish the distance wind. So the distant wind is the one creating the big waves, right? And we can also reduce the local ripples because if there is not so much wind, we can have something almost clear, right? So now it's the perfect time to, we can see the screen space reflections that I was mentioning, which are part of the water system. So now it's the perfect time to play with balls. So I will throw some balls on the water. And so what they do is, what we have in the system, you can sample the water height. So even if there will be waves, we could sample where it hits. And we generate a shadow graph shader. And then we generate a decal, as I was mentioning, so that we have the splash on the water. So it's nice, but what we would like, if that would be a real ball, it's that it generates some ripples, right? So for this, we can deform the water system. So I can just enable deformation, and now if you look, when I throw a ball, you will see that it generates some ripples. Do you see the ripples? Yes? So what we see is that they are not super high quality, which is, I mean, it's great for performance. But the thing is, you can go into a debug mode here and look at the deformation space, because we are allowed to deform on all this space here. So what we can do is reduce the area and say we only want, we only want to deform 50 meters around my camera, for example. So let's go back to this debug mode. Now you should see much better ripples, you see? And you see it's real deformation, because when I throw a ball, the wave is actually pushing the other balls on the water. So it's pretty nice. So let's go underwater. And let's go down, oops, here. Perfect. So let's go underwater. You see it's not really beautiful. It's because we have not activated underwater rendering. So we activate underwater rendering. We can see that these are the parameters, and we want the absorption to be a bit less. Right? So now we have the water rendering pretty nice. What we are missing here is caustics, you know, like the thing that you have in the swimming pool very often. So again, you can directly enable this here. Where are they? Up. I lost my caustics. Here. So I enable them. It doesn't change much. It's because they are simulated based on the waves on the surface, right? So if there are not many waves, there shouldn't be a lot of caustics. So I will need to push a bit the little ripples. So I will add them. You should see appearing the caustics on the floor. I can push them a bit stronger so that I can they can be a bit stronger. Now we have nice caustics on the ground. I like this, it's pretty nice, but there is one thing which is missing. You know, the water line is not perfect, I think. So what you can do a post-process effect that will sample where the water line is. So for example, here, we have a custom effect which is made, again, with shader graph, where that I can enable, and that will simulate the blurry aspect of the line when it hits the lens of the camera. And because it's a full screen effect, I can also generate some drops on the lens, which only be outside of the water, because you can have drops underwater, you know, and I can simulate the water drops this way. Yeah, okay. So 10 minutes left. And so pretty nice underwater rendering. One thing which is missing still is that I can maybe add some details. So we added some VFX graph effect. So for example, we have some fishes which are generated by the VFX graph. All the trees, sorry, not the trees, how is it called in English? The algas are generated by VFX graph, so that it's very efficient. And you can see some little particles floating as well, which is making it realistic. But one thing which is missing is, like, underwater, you have a kind of fog which is created by the thickness of the water. So what I can do is something new we support, is just add volumetric fog to the scene, and it will automatically work underwater as well. So let's look at this here. So now you see that we really have the caustics underwater, which are sampling the caustic buffer that we've seen, so that they generate this kind of a light shaft. So if you, depending on the water you will have different light shafts. So pretty nice, right? Let me finish with the cloud, so I will just move back up here. So as you can see, we have something nice with the volumetric fog. You can see it kind of simulates the atmospheric scattering on the back here to make everything look nice. But the thing is, like, volumetric fog can be very expensive if you want to place it so far away, like as far as the mountains. So to make it cheaper, we actually added atmospheric scattering to the sky rendering, which will allow you to not use volumetric fog too far. So, And the second aspect is also, like you see, the clouds are very dark underneath. And they are very dark because usually the atmosphere should filter that darkness because it's very far away in the atmosphere. And so again, the atmospheric scattering will help you doing this. So okay, I will enable that. So you see, now the clouds are much more realistic. I can move a bit the lighting because the light is going into the sun. I will change the time of day a bit here. So you can see we have pretty nice rendering, right? If I would turn that off again here, we would have something not as physically based. And I don't know if you noticed something, but it's something that I learned when we did this. You know, like you see that the sky is a bit green, right? And it's because when in our simulation we realized that we are missing the simulation of one chemical component of the atmosphere, which is the ozone. And the ozone, when you have light going through a lot of ozone, it's going to turn a bit purple. But when the light is during the day, it hits the surface of the Earth, of the atmosphere, through a thin layer. But when you have a sunset, it goes through a bigger thickness of atmosphere, and so the light is turning purple. That's why you have like purple sunset. So let me show you when we add ozone layer. It's very subtle, but it's just because now it's realistic. The fact that it's a bit purple, right? Now it's very green, and now it's very realistic. So just to finish, we also added a night support. So I will go into the night now. And you will see that the sky has some stars. And again, it's because we can, the same way as I was customizing the shader for the water, we can customize the shader for the sky. So if I go there, like in the physical sky, you can see it's a special shader. And we can, for example, I will pause here. So for example, we can say, I want stars to be much more exposed than they are in reality, you know, and you have something here a bit exaggerated, or I want something more realistic, where you almost don't see the stars like this. So it's all coded into the shader. And also we added like the support, so you can create, for example, a directional light, which will be the moon. And so same thing, you know, like this is the size of the moon, and it can be boring. Here, directly in the light, you can choose, for example, the phase of the moon. We can choose the size of it to make it a bit more romantic. You can choose the rotation phase, depending on where you're on Earth. And you can also, like, I don't know if you realize in real life, but how much you see the hidden face of the moon depends on how much light is bouncing on Earth. It's called Earth shine. So you can, in some days, no light is bouncing and you really see half of the moon. Some days you have a lot of light bouncing on the oceans and so on, and you have an almost, even if it's half moon, you can see the other side. So basically that's it, just a little demo in Unity. Yeah. So I'm going back. 5 minutes. Okay, wow. Okay. So I won't have time to finish everything, but you can ask questions after. Very quickly. Yes, okay. So when you want to do high-end characters, it can be very... All the shaders which are available, like the skin shader, eye shader, a package that you can download, which I will go very quickly because we don't have much time. So with Shader Graph, as I showed, you can do shaders, you can do your own custom textures, you can do full screen effects, you can customize the water. We have material variant. I can talk about this later. This is a full screen master node that I mentioned. We have actually, also if you use Unity and you want to learn about all these systems, we have tons of samples. So you know the package manager that I talked about where you can download some additional packages. If you go in the HDRP package, there is a sample tab, and there you can learn about, for example, you have tons of full-screen effects that you can learn from so that you learn how to do them. Like most of the things that I've shown on the water are part of different samples as well. And yeah, we have many things. So I won't go through all of them. So these are some of the templates. So for example, VFX Graph, they have learning samples where you have about 30 different VFX which are already created to explain all the concept of VFX that you can reuse. Where you can learn what the nodes are doing and how they work. I'm too long, right? The 2 hours is killing all the things. But we have adaptive probe volumes. Okay. Really recommend watching. There are great talks about adaptive probe volumes, which are the way to. And optimizing some tips very quickly. No, I won't do some tips. You ask me outside. I can't believe that 2 hours were not enough. I'm surprised. Anyway, but it was great to just discuss with you, so thanks a lot. Maybe a question. We have 1 minute or two. You know what? Maybe let's discuss outside. Okay. It's okay? Thanks a lot. You were fantastic. Thank you.